Number 3 is an absolute value. And also, please remember, yesterday I told you that this was a typo in here. That actually should have been a less than symbol. So, graphing this one, this is going to be a V-shaped graph because it's an absolute value. So we have to first find our vertex, which is located where? 1, 0. So if you thought of this as shift, then that means our parent function is going from 0, 0 to 1, 0. Everything is getting shifted to the right 1. Okay? But now with absolute values, there's a nice little shortcut so that we don't have to plot points. We could if we wanted to, but we don't have to. Because our A value not only tells us that this V is going to be opening up, but A also gives us the slope of the right side of our V. Okay? Remember that V graphs, absolute value graphs, have an axis of symmetry that goes vertically through the vertex. And then the right side of our graph is going to have a slope of 3. So we go up 3 to the right 1. And you mirror those to the other side. So there's our V shape. We have to decide now, do we graph this with a solid or a dashed line? This is going to be a dashed line because it is just less than, not or equal to. So therefore, we go with a dashed line. Okay. Next, we have to decide to shade, because this is an inequality. Inequalities we shade. Okay, so we've got to decide which side of our graph to shade. What's a good test point for us? 0, 0 is a great test point. So we take our test point, 0, 0, and we plug it into the original inequality. So we have 0 is less than 3 times the absolute value of 0 minus 1. Well, what is 0 minus 1? So we have 3 times the absolute value of negative 1. What's the absolute value of negative 1? 1. So we have 3 times 1, which is 3. So is 0 less than 3? Yes. That's true. So that means this is the true side. Inside is the false side. You always shade the true side of your graph. Always shade the true side of your graph. Questions on number 3? Anything else from this assignment you'd like to see? Yes, ma'am. Number 8, sure will. Okay, looking at 8, we have a square root function. So that means our graph is going to be a curve. Remember, it curves either up to the right or down to the right. That's our only two options. Now, looking at the equation, A is 2. So that's positive 2. Okay, well, so is it going to open up to the right or down to the right? Up to the right. So it's going to look something like that, going up and to the right. Okay? Well, next we've got to talk about our shift. If you think of this as an absolute value function, where's your vertex? 1, negative 4. X is hexed, y is y's, right? Okay, well, we don't really have a vertex. We have a starting point. But we do need to talk about where that starting point is being shifted to. So if the parent function starts at 0, 0, and our starting point is at 1, negative 4, where is everything being shifted to? Right 1, down 4. Okay, and you can look at that vertex. Well, 1, it's positive, so that's saying to the right 1. -4, that's negative. That's saying down 4. Okay, that's our shift. Now, when you graph these, you need to very literally cover up the shift in the equation. We already know what the shift is. We don't need it in the equation anymore. We want to graph or plot points for just that part. Y equals 2 square root of x. Okay? So I'm going to go through and I am going to plot points here. Oops, I got x and y. My x values I pick are 0, 1, 4, and 9. So then I plug those in to get my y values. When I plug in 0, what do I get for y?
0.
When I plug in 1, what do I get? 2. When I plug in 4,
4.
I get 4. When I plug in 9,
6.
I get 6. Any questions on doing that? And where those values are coming from? None? Okay, now remember, these values are before the shift. Okay? Those are before the shift. So we got 0, 0, 1, 2, 4, 4, and 9, 6, which is just barely off our graph there. Each one of those points needs to be shifted to the right 1, down 4. Okay? And so then this is our graph. Questions on number 8. Well, then I have a question for you. Do you guys understand why I'm having you guys plot these points before the shift? Without that shift, you just cover that part up and plot those points?
So we don't mess up when someone do it on a test.
Kind of. I'm trying to give you a set way of doing this. Kind of. It also, it's the big point is so that you can find easy numbers to plug in. Plugging into these should never be a difficult thing. Finding your x and y's should never be hard. Okay? Because of the way we're working this. We're always going to be taking the square root of 0, 1, 4, and 9. You guys can all do that. And then it's going to be a matter of taking that square root times whatever your a value ends up being for this particular equation. Okay? So that should never be a terribly difficult thing. Now, on the other hand, if you came back here and you didn't get rid of the shift, and let's say you try to plug in for x now. Well, okay, so if I plug in for x and y, and I got 0, 1, 4, and 9, if I plug in 0 for x, what's 0 minus 1? -1. So then I've got to take the square root of -1.
I squared.
I. The square root of -1 is I. That's an imaginary number. I can't plot an imaginary number, so I can't do that one. What if I plug in 1? What's 1 minus 1? 0. I can take the square root of 0. That's 0. Okay, so then 0 times 2, that's 0. 0 minus 4, -4. So I can do that. What if I plug in 4? What's 4 minus 1? 3. What's the square root of 3? Again, we don't know it off the top of our head. It becomes nastier numbers this way. Okay? So if we always figure out what our shift is first, then ignore that part of the equation, we can always plot nice, easy numbers to graph. And then taking those easy numbers to graph, we can move them according to the shift. Okay? That's why we do it that way. It's to give us easier numbers to work with. Okay? Any questions on that? Anything else you'd like to see from this assignment? Yes, sir. Number 11. All right, let's take a look at number 9.
Isn't it A is
never to the left.
Down to the right.
All of these graphs always go to the right. If A is positive, they go up to the right. If A is negative, they go down to the right. Okay? But they always go to the right. So do we still need to see this one then? You want to see that one? Okay. So, taking a look here. First off, please remember the standard form for a square root function, or the general form I should call it, is y equals a times the square root of x minus h plus k. Now, the x minus h is underneath the radical. The radical stops. Okay? So do we have anything underneath the radical with our x in this problem? No. So that means we're not shifting left and right because there's nothing with the x. But we do have something outside the radical. Okay? So that tells us we're shifting where? Up or down, which in this case we shift up 5. Okay, another way of thinking about this is just like with absolute values, finding the vertex of the absolute value. If this was an absolute value problem, if instead of having the square roots, we had an absolute value, where's your vertex for the absolute value? 0, 5. Well, if you look at this as being the vertex, 0, 5, well, we don't really have vertices or a vertex for square root functions, but we do have a starting point. So the parent function starts at 0, 0, just like the vertex for an absolute value starts at 0, 0. But ours is supposed to be at 0, 5, up here. So how did we shift from the red dot to the black dot? Up 5. Okay? That's all we're doing. Just find your vertex, and that tells you where you're shifting. Okay? Questions on that part? Okay, so we have this. Now, when we go to plot points, we want to plot the equation without the shift. We already know the shift, we want to plot it without the shift. So we have y equals negative 4 times the square root of x. You don't put the plus 5 on there as well. Okay? So we're plotting points for this. We have x and y. Our friendly numbers 0, 1, 4, 9. We plug into that question? Yes?
Miss Bushman mentioned something about instead of plotting points,
Ignore it. I'll talk to Miss Bushelman. That shortcut's far too short. Please plot the points. Okay? So, 0, 1, 4, 9. We plug that in. Negative 4 times 0. Negative 4 times 1. Negative 4. Negative 4 times 2, because remember the square root of 4 is 2. Negative 8. Negative 4 times the square root of 9. Okay, so there's our points. Now remember, that is the coordinates before the shift. So if we plot those guys, we're at 0, 0. We're at 1, negative 4. We're at 4, negative 8. And then 9, negative 12 goes way off our graph. Those points need to be shifted, excuse me, they need to be shifted up 5. Okay? They all need to be shifted up 5. And so our graph is going to look something like that. Questions? Are you sure? Yes, ma'am. Number 3, I sure can. Number 3 is not. Number 11. Okay, on number 11, I really want you to think back to when we were graphing lines. If I gave you the equation y equals 5 plus x, that's not in slope-intercept form. So what would you do? I'm not talking about that equation. I'm talking about y equals 5 plus x. What would I do? Those of you who are telling me to subtract stuff, I'm not trying to switch the sides. I'm not trying to move across the equal sign.
You just reorder it.
I just reorder it. I just flip those guys around. That's all I need to do. Well, same thing goes here. I'm not trying to cross that equal sign. All I want to do is reorder this. I got a negative 2 and a 2 square root of x. Just flip them around. So our equation should be y equals 2 square root of x plus a negative 2, or minus 2. That we can graph. What's our shift?
Up 2. Down 2.
Wait, no, oh, yeah.
Down 2. There is no x shift because there's nothing inside the square root with us, right? So we're just shifting down 2. Now, to plot points, we ignore the shift, and we only plot points for y equals 2 square root of x. So we use our friendly numbers, and when we plug these in, what do we get for our y values?
2. 4.
Okay, well, we plot those points, 0, 0, 1, 2, 4, 4, and 9, 6. But again, that is before the shift. We have to shift everything down 2. So this is our graph. Questions? Are you sure? Okay, so again, in 6.8, the general form for our square root functions are f of x, which remember f of x is just y. So y equals a times the square root of x minus h plus k. That value inside the radical, that value of h, tells us if we're moving left or right. And that's always opposite what it says. If it says plus 2, you move left 2. Right? So that's why we say x is hexed. It has to be attached to the x in order to move us left and right. What's outside the radical moves us up and down. And we say y is y's. So therefore it moves us in the order it's supposed to move us. Okay? Okay, but if that's going to be moving us up and down. Now a, when we were talking about absolute value, a gave us the slope of the right side. Okay? Well, curves don't have a slope. So a is no longer a slope of the right side. We can't use that shortcut here. Okay? But what we can do is have a tell us whether or not we're opening up or down. Okay? That's what a does for us. And that's what a did for us in absolute values as well. It also happened to be the slope of that side, or that right side. Okay, but right now, all a does us is tell us if we're opening up or down. And please remember that if A is positive, what we mean by opening up literally means from your starting point, you go up and curve to the right. Please make sure you're thinking about this the right way, okay? It's not going like this. You don't go right and curve up. You go up and curve right. Okay? And then if A is negative, we go from our starting point, we go down and curve to the right. Okay? With square root functions, we're always going to the right. We do not go to the left, ever. Either curve up and to the right or down and to the right. All right? Any questions? All right, then I want you guys to try a couple of examples today. So on the front side of your notes there, on the bottom left, we have this example here, y equals the square root of x plus 1. I would like you to work this one alone, and then double check your answers with your neighbors. Go. Okay, folks, I'm seeing some good answers. I'm seeing some folks who are still a little bit confused here. So looking at this, first off, if you look closely at this radical, that radical bar does not extend clear out over the plus 1. It stops right there. Okay? And in fact, in a lot of other countries, in the U.S., we don't teach to put that little tail on our square roots. But a lot of countries do teach to put that little tail on your square roots, because that's where it stops. Okay? So if that's where it stops, do we have a left or right shift? No, because there's a 0 in there with it, right? It's like saying x plus 0 under the radical. So we do not shift left and right. This plus 1 is outside the radical, so therefore we shift up 1. Because what's outside the radical shifts us up and down. Okay? So we shift up 1. Now, when we graph this, or we plot points, you only plot points for the part of the equation without the shift. So you get rid of that plus 1. We just want to plot points for y equals the square root of x. We want to pick our friendly numbers, 0, 1, 4, 9, and we want to plug those in. So if I plug in 0, the square root of 0 is 0. If I plug in 1, the square root of 1 is 1. If I plug in 4, the square root of 4 is 2. And if I plug in 9, the square root of 9 is 3. So now what we want to do is we want to take these points, because this is before the shift. That's before the shift. I want to take those 4 points and plot those points. 0, 0, 1, 1, 4, 2, 9, 3. I'm taking those 4 points and I'm going to shift those all up 1. So every single point just moves up 1 unit. That then gives us our graph. Questions? No questions on this one, are we sure?
So if it was inside the radical, it would be left or right?
If it was inside the radical with the x, then it moves us left and right. Yes. Okay. Let's try another example. Back side of your notes. On the back side of our notes, we have one left. The first one there, we have y equals the square root of x plus 4. Y equals the square root of x plus 4. I would like you to work this one on your own. Check your answer with your neighbor. Okay, looking at this, we have a plus 4 inside the square root with our x. Right? That radical symbol stops right there. Okay? So therefore we have nothing outside there. There's nothing added on at the end. So our shift, remember x is hexed, so whatever is in there with the x, we do opposite what it says. It says plus 4, therefore we have to move left 4. All right? Now, to plot points, we ignore the shift, and we just want to plot points for y equals the square root of x. So we plot points. We use our friendly numbers. Okay, again, we're using those same numbers all the time. This should get real quick for how to do that. Please put the book away. So plugging in for x, what's the square root of 0? You're right, it's 0. What's the square root of 1?
1.
Square root of 4. Square root of 9. Now, again, those are before the shift. So if you want, I've seen a few people doing this, which is a good idea, don't plot these as actual points. These are our starting spots, so maybe you plot them as little x's. So 0, 0, 1, 1, 4, 2, and 9, 3. Those are our starting points. Each one of those points needs to get shifted left 4. So each point goes to the left 4, brings us here, 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 and here. So that's now our graph. Connect the dots using a curve. Again, going up and to the right. Well, up and to the right. Okay? Questions on this? Is there anything else I can do to help this make more sense to you?